Hello there, this is an Algebra 1 video. It is Chapter 8, Section 1. And today we are learning about adding and subtracting polynomials. Yay! Before we get started, I want to give you guys some vocab. A polynomial is any monomial or sum of monomials. And if you don't know what a monomial is, the root word here being mono, or the prefix, sorry, of mono, means one. So it basically means one term. Or you can have a sum of monomials. So here we have some examples. This is a monomial right here. It's one term. But we also have, these are all polynomials, by the way. This is a monomial. It has one term. This has two terms. So we've got the 2x squared and the 7. So you have two terms there. And then this guy has three terms. So we call that a trinomial. So binomial for 2 and trinomial for 3. But one thing that I want to be very clear about is that when you look at a polynomial, the terms are separated by addition and subtraction, always, not by multiplication. So for example, you might be thinking, well, is 2 a monomial and x squared a monomial? Is that two different terms? No, because that's 2 times x squared. So that's all one term. Same thing over here with the 10x. You have this subtraction symbol and this addition symbol, and so you have one term, two terms, three terms, trinomial. So your terms are always going to be separated by addition or subtraction. And so we also have names for the degree of the terms. So basically, if you have a 0 or no variable, then you're going to call that a constant term. So basically what I want to do here is you have 5x. The degree of this little guy is 1 because it's x to the 1 power. So the degree of the term is 1. But then in this case, you have two different degrees because the first term has a degree of 2 because it's x squared. But the second term doesn't have a variable at all. So its degree would be 0. So basically you can imagine that it's an x to the 0 power. And we already know from the previous chapter that x to the 0 power, anything to the 0 power is 1. So that would be 7 times 1 or just 7. So it's the same thing. But that's why we call this having a 0 degree, because the exponent would be 0. So you have two different degrees here. You have the degree of the first term is 2. The degree of the second term is 0. So then how do we determine what the degree of the polynomial is? So there's two different types of degrees that you'd have to have. There's the degree of the term itself, of each individual term, and then there's the degree of the polynomial as a whole. So if you only have one term, then the degree of the term and the degree of the polynomial are the same. It would be 1. But in the case where you have two terms, you have two different degrees. The degree of the first term is 2, the degree of the second term is 0. But the degree of the polynomial as a whole is always going to be the larger of the two. So that would be the 2 here. All right, then you have the last one where you have 3 terms. So the degree of the first term is 3 because it's x cubed. The degree of the second term is 1 because it's x to the 1 power. The degree of the last term is 0 because it doesn't have a variable. So each term has its individual degree. But when you talk about the degree of the polynomial as a whole, it's going to be a 3 because 3 is the largest of all 3 of the terms. So that's how you do that. So be careful that you give the right thing. If they're asking for the degree of each term, then you can do that. But if they're asking for the degree of the polynomial, then you have to give the largest degree of any of the terms that are in the polynomial. And then we have names based on the degrees for our polynomials. So here we have a list. If you have a 0 degree, 1 degree, 2nd degree, 3rd degree, 4th, 5th, 6th, and so on. So if you have a 0 degree, we call that a constant term, like the 7 or the 1. If you have an x to the 1 power, that's a linear term, so we call that linear, like the 5x here, or the 10x in the last one. If you have 2, we call that quadratic, like the 2x squared. We have 3, then we call that a cubic, like the x cubed here. And then at that point, if you have beyond that, you have 4th is quartic, 5 is a quintic, and then if you get to 6 or more, we don't have a specific name anymore at that point. We just call it 6th degree, 7th degree, 10th degree, 11th degree, and on the story goes. All right. So it says here in example 1, determine whether each expression is a polynomial. That's the first thing we have to do is it or is it not a polynomial? If it is a polynomial, then they want us to find the degree and determine whether it's a monomial, binomial, or trinomial. So remember, the degree would be based on the exponent, and the term of monomial, binomial, or trinomial depends on how many terms the polynomial has. So for part A, we have here yes. This is a big fat yes. So I want to let you know that it's totally okay to have more than one variable, like the 5xz. That is not a problem. But when you have more than one variable and you're trying to find the degree, you have to add the exponent. So here we have 4y to the first and 5x to the first, z to the first. So when you have more than one variable, you want to add those exponents together. So the degree of the first term is 1 because it only has one variable, the y. But the degree of the second term has an x to the 1 and a z to the 1. So this degree is actually 2. So the degree of the first one is 1, the degree of the second term is 2. So when you think about the degree of the polynomial, which one is bigger? The 2. So we answered the first question that yes, it's a polynomial. And then we found the degree of each term. And then it says determine whether it's a monomial, binomial, or trinomial. This is a binomial because it has 2 terms. And the degree is going to be 2. And there we go. And so now for part B, we have another polynomial. And you might be thinking this is not a polynomial because it doesn't have a variable. But it's totally okay to have a polynomial that only has a constant term. We said before that if you don't have a variable, you're considered a degree of 0. And that is what we call constant. So this is yes. It's a monomial because it only has one term. And its degree is going to be 0 because it has no variable. Alrighty. Then in part C, this is a big fat no. And the reason why it's a no is because although it's okay to have different variables, like in part A, you can't have negative exponents. So this a to the negative 3 power is no bueno. So that means it's going to be a no. Therefore, we don't have to worry about the degree, and we don't have to worry about whether it's a monomial, binomial, trinomial. It's just going to be a big fat no. All right, in part D, we have a little bit of a trick question, so to speak. Because these two terms here, the 4x and the plus x, are the same variable. They're like terms. So we can actually simplify this problem to 6x cubed plus 5x plus 3 because you have 4x and plus x is going to be 5x. So now the answer is yes, it is a polynomial. It has 3 terms, so we're going to call that a trinomial. If you hadn't combined the 4x and the x from the get-go, trinomial, then you might have thought it was a quartic, but it's not a quartic because you can combine 4x and x to 5x. And the degree is going to be 3 because that is the largest degree of any of the terms. This term has a degree of 0, this term has a degree of 1, and this term has a degree of 3, and it's the largest, so the degree of the polynomial is 3 as well. So that is how you do that. And now we're going to let you do these little guys on your own before we move on to standard form. And we kind of hinted at that in part D of the first example. Standard form is when you put the terms of the polynomial in order from greatest degree to least degree, but also you want to combine any like terms before you do that. When you have something in standard form, the very first term is what we refer to as the leading coefficient. So the leading term actually, and the leading coefficient is obviously the coefficient of the leading term. So we'll show you that in this example, how that works. It says write each polynomial in standard form. So clearly the x to the 5th is larger than x squared, so this is not in the right order. So we need to rearrange the order here. So we're going to put 4x to the 5th first, and then plus 3x squared, and then minus 7x. So now they're all in the right order from biggest degree to smallest degree. And since this is the first term in the polynomial, it's considered the leading term. And since they're asking us to identify the leading coefficient, the LC if you will, that's just the coefficient of the biggest or the first term, so it's just the 4. Be very careful that they don't want the entire term, they just want the leading coefficient, so it's just the number in front of the variable that happens to be the first one. It's leading the pack, so to speak. So there you go. It's going to be a big fat 4. All right, so then we're going to do part B. Same thing. We want to put this in the right order. So we're going to put negative 2y to the 4th first. And then we're going to get minus 6y cubed. And then we're going to go plus 5y minus 9. So now we have 4th degree, 3rd degree, 1 degree, and then 0 degree. So they're in order from biggest to smallest. It doesn't matter if it's negative or positive, it's based on the exponent. So the 4 goes first. So this is now going to be my leading term. And the leading coefficient is the number in front of that leading term, which is negative dose. And that is how you do that. So now you can try this little guy on your own, and then we'll move on to adding and subtracting polynomials. When you're adding and subtracting polynomials, it's very important. There's actually 2 ways to do it. I prefer the vertical method, so I'm going to be using that method. But basically, you can add any like terms together. So you can add x squared with x squared, but you can't add x squared with x, okay? So you've got to put all of your like terms together, and so you can do that horizontally, or you can do it vertically, and I prefer to do it vertically, so I'll show you what that means. I'll take, here's my first polynomial, I'm going to add it to this one. This 3 is a constant term, and the negative 7 is a constant term, and this is plus 3, so I'm going to go ahead and just write it underneath it. That's why we call it vertical. Then we have plus negative 4x squared, so I'm going to put the negative 4x squared underneath the 2x squared. And then we have the plus 6x, and I'm going to put the plus 6x underneath the 5x. And then we're just going to combine our like terms, just add them together. So what is 2 minus 4? Negative 2x squared. What's 5 plus 6? 11x. What's negative 7 plus 3? Negative 4. And that is how difficult it is for you to add 2 polynomials together. Not difficult at all. All right, so now we're trying another one over here. And we've got 4 terms here, and we have 3 terms over there. So it's probably going to be easier for us to take these terms and put them underneath over here. It doesn't matter which order you add in. It does matter which order you subtract in, however. So I'm going to go ahead and stay with the same order from before. And we're going to take 4y squared. You'll notice that in this term there is no 4y squared. So I'm just going to put the 4y squared over here off to the side. And then we have negative 4y. And we're going to put the negative 4y with the 3y. And then we have 2y cubed. That's going to go right here with this y cubed. And then we have plus 8. And then we're going to add them together. And since the 4y squared doesn't have any other like terms, it's just going to stay 4y squared. And then 3 minus 4 is negative 1y. And 1y cubed plus 2y cubed is now 3y cubed. Yeah. And negative 5 plus 8 is going to be a positive 3. And that will be your answer for part B, 4y squared minus y plus 3y cubed plus 3. Now, if you wanted to put this in standard form, which you should always write your answers in standard form, then we have to make sure that we put the 3y cubed first because it has the higher degree. So technically the answer should be 3y cubed plus 4y squared minus y plus 3 if you wanted it in standard form, which of course we do. So there's actually your answer. So now we'll let you do this example on your own, and then we'll do a subtraction one, which is pretty much done exactly the same way. The only thing you have to be careful with subtraction is that you distribute the negative to all of the terms. That's the only thing that students forget to do all the time. But you're not going to do that because you're going to be really cool about it. All right, so here we go. 4x. This is negative 4x. So we're going to put it underneath the negative 2x. Then we have negative and negative, so that's going to be a positive 5, and that's a constant term, so we're going to put that underneath the 3. And then we have negative 3x squared, and the negative 3x squared is going to be with the 2x squared, and we're going to add those together. So 3 and 5 is 8. Negative 2 and negative 4 is negative 6x. 2 minus 3 is negative x squared, and of course you want to put this in standard form, so the negative x squared should go first, minus 6x plus 8. Negative x squared minus 6x plus 8. And then we'll do the same thing over here. We've got negative 3p squared, but there is no p squared term here, so we're going to put it off to the side. Then we have negative 2. And that's going to go with the negative 8. Then we have negative and negative, which is positive 9p. And that's going to go right here. And then we're going to combine those together. So we're going to get negative 3p squared 9p and 7p is going to be 16p. And then the 4p cubed doesn't have anything to add with, so it's just going to be 4p cubed. And then negative 8 minus 2 is going to be negative 10. And of course, to put it in standard form, we want the 4p cubed to go first, having the highest degree. And then we'll go to the squared, negative 3p squared, plus 16p minus 10. And that is your final answer. 4p cubed minus 3p squared plus 16p minus 10. So now you can try this do-it-yourself question, and then we will go to our last example for this lesson. And here it is. The equations p equals 7m plus 137 and c equals 4m plus 78 represent the number of cell phones, p, so p represents cell phones, and digital cameras, c, so the variable c represents digital cameras, that are sold in m months at an electronics store. Write an equation for the total monthly sales t of phones and cameras. So basically what they're telling us here is that t is going to represent the total monthly sales. So total monthly sales meaning total between phones and cameras. And since phones is p and cameras is c, we basically have that t equals p plus c. And since we know that p equals 7m plus 137, we can substitute p with 7m plus 137, and we can replace c with 4m plus 78. All right, and hence why it says in the second portion, it says predict the number of phones and cameras sold in 10 months. So first we're going to combine these two equations. So we're basically adding two separate polynomials together. And so again, if we use our vertical method, these 4m's are going to come over here with the 7m's, and these 78 are going to be over here with the 137. So 7m plus 4m is 11m. And then 137 plus 78 is going to give us 215. So this is now our equation of the sum of both phones and cameras for the total monthly sales. And it says they want us to know, they want us to predict how many phones and cameras will sold in 10 months. That means we're going to replace the m with 10 for 10 months. And then evaluate. So 11 times 10 is 110. And then we're going to add 215 to that. And we're going to end up with total sales of phones and cameras at 325 phones and cameras. All right, in 10 months of sales. So now in this last do-it-yourself question, you want to use the same information from example 5 that we just did, only this time you want to find the difference in monthly sales and at 24 months. So you want to use subtraction instead of addition for that one. But once you've completed this example, you will have completed your notes for this lesson, and I will see you in class. And thank you for watching.